Permeability defines the ability of a reservoir to permit the flow of fluids. It is measured in darcies or millidarcies and is represented by the letter kappa. A permeability value can be indicated, but not directly measured from well-logged data. Core analysis, however, can provide an actual measurement.
According to Darcy's law, the volume of fluid flow per unit of time, Q, is equal to the negative of the permeability multiplied by the cross-sectional area, multiplied by the pressure gradient, and divided by the viscosity of the fluid and the length of the rock sample.
Therefore, the permeability is 1 darcy when 1 cubic centimeter of fluid flows in 1 second through a medium that is 1 square centimeter in cross-sectional area and 1 centimeter in length, under a pressure differential of 1 atmosphere per centimeter, where the fluid has a viscosity of 1 centipoise. Permeability is controlled by the size of the pore throats, the connecting passages between pores. Permeability often decreases with depth because compaction and cementation restricts or blocks fluid pathways, and therefore reduces flow rate. When only one fluid, such as water, exists in the pores, its permeability is known as absolute permeability, K. When 2 fluids are present, such as oil and water, the permeability of the oil is known as its effective permeability, K sub O. The effective diameter of the pores through which the oil is flowing is reduced by the water, which adheres to the grains. Therefore, effective permeability is less than absolute permeability. And finally, relative permeability, K sub RO, is the ratio of the effective permeability of a given fluid to its absolute permeability. Standard curves plot the relative permeabilities of the 2 fluids as a function of water saturation. Thus, in a typical relative permeability curve, we see that at low water saturation, only oil will flow. As the water saturation increases, the relative permeability of the oil decreases until some critical level is reached, at which both oil and water flow. The oil flow continues to decrease and the water flow to increase as water saturation increases. At some level of water saturation, oil no longer flows and only water flows. Beyond this point, as water saturation increases, the flow of water within the rock continues to increase.